Welcome to Macros and Blueprints with the subtitle, Harnessing Macros and Blueprints for Efficient Code Generation. In this section, we'll explore how macros and blueprints in Sheerpower streamline code generation by allowing you to define reusable templates and automate repetitive tasks. By mastering these tools, you'll enhance both efficiency and consistency in your code, making your development process faster and more scalable. Let's dive into how macros and blueprints can transform your coding workflow. Macros and blueprints in Sheerpower transform code management by minimizing redundancy, making code easy to maintain, and accelerating development. These tools create reusable patterns that enhance productivity and simplify updates. Let's explore how to make the most of them. Macros allow concise, parameterized code snippets, while blueprints handle more structured, larger blocks of reusable logic. Both tools standardize repetitive elements and help developers work more efficiently. Macros provide a single expansion at each instance, making them ideal for smaller patterns, while blueprints generate a new code copy for each argument, handling larger, structured logic well. Understanding these differences helps choose the best tool for each task. Macros and blueprints standardize code across team projects, ensuring consistency, boosting reusability, and reducing errors. They enable teams to maintain a cohesive code base and streamline updates. Blueprints streamline data validation by generating consistent, reusable validation code across different fields, making processes standard and reducing errors in code. In this Sheerpower example, the validator blueprint defines a reusable pattern for validation and storage operations. Within the blueprint, the placeholder is used to indicate a variable section that will be dynamically replaced when the blueprint is generated. When %generate_validator with customer is invoked, placeholder is substituted with customer, resulting in the expanded code. This output shows that validate customer is called first to handle validation tasks for the customer, followed by store customer, which handles storage operations for the same. This pattern is useful for creating consistent, modular validation and storage routines for various entities, such as customer, by simply changing the placeholder during generation. It saves development time and ensures a uniform approach across similar tasks. Blueprints can be extended or prepended with new content, enabling code reuse and modularity. This approach maintains a dry, don't repeat yourself, code base, ensuring structured and flexible development. In this Sheerpower example, 3 blueprints define different handler behaviors. The base handler blueprint introduces a foundational template that prints init placeholder, where placeholder will be dynamically replaced when the blueprint is expanded. Extended handler builds upon base handler with the extends keyword, adding the statement last placeholder after base handler's output. When extended handler is generated with the keyword customer, placeholder is replaced by customer, resulting in an output sequence of init customer followed by last customer. Meanwhile, prepended handler uses prepends to add first placeholder before base handler's content, illustrating how prepending inserts content at the beginning, while extending appends it to the end. This modular design, facilitated by Sheerpower's blueprint system, enables flexible, reusable code that can be easily customized for various contexts. Blueprints support formatting functions that tailor placeholder text, like changing cases, ensuring uniform and readable output, and streamlining code adjustments. In this Sheerpower example, the handler blueprint demonstrates flexible text transformations using placeholders within a blueprint structure. It defines 3 print statements that utilize different variations of the placeholder keyword, allowing for specific case adjustments when the blueprint is expanded. In this case, %generate handler with customer substitutes placeholder with customer and applies transformations based on the specified case methods. .l case converts it to lowercase, .u case to uppercase, and .c case to capitalize the first letter. This example highlights Sheerpower's ability to apply different text transformations within a blueprint, enhancing the flexibility and readability of generated code by dynamically formatting placeholder content. Sequence placeholders allow automatic generation of numbered variables, making it easy to handle repetitive elements in code and ensuring consistency without manual adjustments. This example demonstrates how Sheerpower's blueprints and extensions work to build structured code dynamically. The handler blueprint defines a simple action that appends a placeholder followed by a comma to the variable $. An extended blueprint, handler XX, builds on handler by adding extended each time it's invoked. After initializing $$ to an empty string, %generate handler with age, city, ID populates $$ with age, city, ID, and %generate handler XX with ID __, ID __, sequentially appends ID 01 and ID 02, age X plus, extended. The final printed result demonstrates both the placeholders and extensions in action. Macros support single and multi-line definitions, plus nested macros for added flexibility, allowing for modular code expansion that keeps code concise and manageable. Sheerpower's debugging feature lets you view expanded macros and blueprints, making it easier to validate code and troubleshoot expansions. This tool is invaluable for maintaining complex macro and blueprint implementations. Mastering macros and blueprints will significantly boost your productivity in Sheerpower. These tools streamline development, enhance code consistency, and make maintaining and updating code much easier.